one of my problems that I've never had satisfied is that when I looked at the math of the fall,
Yeah.
right,
Well,
that doesn't seem to reflect it. So I wanted to know with those P900s, how far are they going out? If they're only out a couple miles, then they don't have a case. Here would be the proof of curvature. The proof of curvature, this is why you have to know how far it is you can see with these things. Because proof of curvature, if you could see 10 miles with a camera, if you've got a 25,000
yeah. Well,
mile
what
circumference, then that's impossible,
it over a
right?
certain distances?
Yeah, 10 miles, yeah. Because
Well,
you'd have curvature would be in the way. So
it would
so
be
if you when you
impossible.
zoomed in, you could see that, like, if you can show that the bottom of the boat is disappearing because it's ostensibly going over curvature,
Well, so like one thing you have to understand with atmospheric lensing is that light doesn't always travel in a straight line. So like
right?
there's water particles in the atmosphere.
It,
So like if we look here at see this ship, this is really
yeah.
cool. So you have hot air up here, medium air here, and cold air down here. Since there's less particles, as the light travels through the medium air and cold air, it'll bend more. And this can cause some pretty cool effects. And so this would cause the ship to appear higher than it actually is. You can this is
Yeah,
known as a mirage called the Fata Morgana. It's caused in certain environmental conditions, but
right.
like I'll show you some pretty cool pictures. Yeah, so like clearly this is a lake effect what's going on here, and it's caused the boat to actually flip upside down. So we know this is some sort of lake effect mirage that goes on. But this one's cool. This is not a CGI. There's no magic used in the making of this. This is actually a visual shot of a ship floating in the air. It's the lake effects just happen to be right that they're so strong. Like sometimes it depends on the
I've
wind.
never seen that before. I
No,
thought that was CGI
that's
or
it's
like
not
or
CGI. It's actually somebody viewing a ship from the shoreline, and it appears to be floating in the air. Yeah, you can tell how people may observe
maybe it
this.
is floating in the air.
It's not. No,
I
it's the same fact
don't know.
described right
I
back
didn't used to
here.
think giants were real.
See, this person observer, from his perspective, he sees the ship up like this.
Hmm.
But in reality, what's going on is something more like this. He's seeing the angle of the ship being up here, but really the light got distorted as it came to him. And so it bent down, which caused the ship to appear higher. And that's why sometimes you can see beyond distances which you could normally see if you do curvature math.
All right. Well, then, so the people that are showing us, they're showing us exceptions. Well, I don't want exceptions. I want to know if we go down to Lake Ontario. Like, I
Is
want
to
a measurement over
use.
long distance. I need 5, 10 miles.
I think this is a much better example here. If you look at perspective, right? Something gets closer to you, it gets bigger, right?
Right.
As it gets further away, it gets smaller.
Mhm.
Like flat earthers want to appeal to perspective, it gets smaller and bigger. So that's flat earth model, it gets smaller. So here, let's watch the sun and moon set. So here, you have the sun, it's like at full. It's
Right.
actually a little bit, you can see how it's kind of, the sun appears a little bit squished.
Right.
That's a little bit of atmospheric distortion going on.
Yes, you can see that.
A
Yeah, yeah.
little bit of effect
No,
will
I agree.
happen on
I
that.
agree.
Yeah.
But yeah, because it looks a bit like it's being oblated.
Yeah, because the sun is like an almost perfect circle. It's like one of the most perfect circles I think we've found in the universe, or so far. Like it's
I think if
anyway.
you stare at it long enough, you'll agree.
You'll probably go blind if you stare at it long enough. But yeah. So like the light at the bottom of the sun here is traveling through more of the atmosphere, and so that's why it's causing this to distort a little more than the
Yes.
top part.
Yeah. Yeah. You can see that.
The sun here, look, it's staying the same relative size as it's going beyond the horizon. See? In this shot, half of it's missing. So if you have two scenarios, if it was truly disappearing by perspective, as flat earthers claim, I would expect to see something like this. The sun's full high, it goes further, it gets smaller,
As
smaller,
it's right,
smaller,
of
and smaller,
course.
and then it eventually disappears by perspective. You can't see it anymore.
Hmm.
But we're not seeing that when we watch the sunset. We see it slowly going over an edge. It's staying the same size. You can compare the two shots.
That's a very good point.
And so
Yeah, that's a very
it's
good
not
point.
the flowers they claim it's disappearing by perspective, but it's not doing that. And this is just notice it's clear day, no clouds on the horizon.
No.
And the
But,
moon does the same thing as well. The moon's actually a better choice, in my opinion, because you can see finer details on the moon.
okay. Well,
But,
yeah,
like,
it's
look,
hard
you
to
can
say.
see it's going over, like, even a flat Earth model, the moon should be, like, 3,000 miles above the surface. It's pretty high up there. It shouldn't be going behind a hill. You can see they're just disappearing. But they're not changing size.
Yeah. It's
Mhm.
just.
Yeah, this is a clear day, no clouds. Now, what some flatters have done to try and deal with this is they'll do like a photo like this. You see the sun, oh, it's like at this size,
Well,
right?
hold on. There's not any kind of that atmospheric lensing working in that way with respect to the moon, where it makes it
Yeah.
look.
No, there's no. Well, the thing is, because the moon is staying the same distance away from us, it's not moving through more atmosphere. You're not getting more or less atmospheric lensing. That's why I think it's an ideal experiment to a ship. You can get much clearer conditions. Now, of course, in a flat Earth model, the moon would probably be getting more atmospheric lensing, but even still, you shouldn't ever be able to see objects disappear.
Yeah.
But
No,
and
it's a good argument.
one thing important to note is
Excuse
like
me.
sometimes flatters will show footage like this. So you see the sun at this size,
Yeah.
and then in the next slide you'll see, oh, it looks a little bigger, right?
Right.
So what's going on in these circumstances?
Well, they're two different days.
Nope, these are both snapshots of the same video, same footage, but you do see the sun appearing to look bigger. What's going on here is that this is going on when there's clouds on the horizon. So you want to do this experiment on a clear day. So like
Okay. Yeah. Yeah.
see all these
To
clouds
get
on the
to.
horizon, they're dampening the light
Yeah. Yeah.
and getting bigger here. So what's going on is that it's not a good. What happens is when
If it
sun,
was above clouds
yeah,
and then it goes into the clouds, you
hmm
get that effect.
yeah, exactly.
But
hmm
if you can see it on a clear
So
day, it's going to stay
and
the
that's
same
why this is
size.
superior. Like this is a clear day, same size, and if it was actually disappearing by perspective, it couldn't ever be the case
Right. So you have to
that.
pick your poison there. Yeah.
Well, no, if it's a clear day here, it always stays the same size. And if it was disappearing by perspective, it should never do this. Like, think about anything moving away from you. It should be getting smaller. It should be going to full size, shrinking it down to like an infinitely small dot, and disappearing. And it should be doing that every day consistently. But it
Right.
doesn't. Yeah, and then there's this shot here. Like, also, like, why is the bottom of the clouds lit up, where the top of the cloud's dark? See, in a round Earth model, makes sense because like the sunlight is coming up through the atmosphere now and hitting the bottoms of the clouds. This doesn't make sense in the way that flat earthers believe their sun is disappearing by perspective. You
Right.
shouldn't be seeing the bottoms of the clouds lit up and the tops of the clouds dark. That doesn't work. Yeah, and my point is ancient people are
What
smart
if it
enough to
was?
figure this
What
out.
if we? Okay, so we know they believed in the dome, and there's no problem. I guess. See, I don't have to have, and I
Well,
never had a problem with the fact that if they believed that the world was flat in the past,
mhm.
and we believe it to be round now, that doesn't interfere with my take on the Bible. Like
Yeah.
I don't see the Bible suffering for that because
Well,
it's because that is creates a straw man that is
mhm.
deposit that
Yeah.
the Bible is supposed to be this quote scientific text, and then God
Yeah.
took this nitrogen
Well,
molecule
it's
and
what's especially weird is they go through like poetic sections of the Bible. It's like if I went to like the writings of like Shakespeare and be like, all the world's
you
a
know
stage, and it's like proof Shakespeare believed it was flat. Well, wait a second. Wait a second.
yeah,
This
that's
is
good.
poetry. You're taking an incredibly poetic section that's not intended to be teaching scientific knowledge and trying to use this to try and say. And I don't have a problem if people in the Bible in that time believed here. It doesn't matter.
No, oh, yeah, we're agreed. So,
Yeah.
but I think for some people it was also that they were feeling like maybe a lot of ridicule, and maybe that because everything we were taught in school was the Bible's is nonsense. Nonsense. It is
If you
the
look at
greatest historic volume available to us, and thankfully
mhm,
we have it because
yeah. And the
you
point
learn
is
so many
it's
things.
history and theology. That's the topic of it. It's
Hmm.
not science. It's
No,
not
it's not supposed to be,
trying to explain.
but it is concerned with truth, and I think
Yeah.
that now you can see spots in the New Testament, specifically like in Acts. Do you really believe? I don't believe that thing where it said and then snakes came out and ate them all or something.
Yeah.
That little story of Paul's kind of thing. That seems to me like an adjunct. But there are little quips in there,
Yeah.
things that are
Also,
interesting from a historic concept.
yeah.
They give you a context, so they serve a different purpose, but
Mhm.
still relative.
Yeah. Yeah, and what some flat earthers will use, trying this sort of science, the idea that light will refract and bend, to try and say that this is why the bottoms of boats and stuff are disappearing. And to say it's atmospheric lensing that's causing it to disappear bottom up. And
Okay.
it's kind of a strange idea.
No, but it could be it could be a good
Well,
argument. Is it in physics?
here's the thing you got to realize: light, as it passes through a denser medium, it will bend towards the denser medium. So in here, light, as it passes through denser medium, it'll bend towards it. So it'll bend down. This causes the object to appear like it's higher than it actually is. Because the guy sees the light coming in at this angle, and so he would conclude that the light.
Isn't he looking at the top of the boat?
Well, so this first one is where the boat actually is, and it's trying to describe how light flows. So it goes through here. It starts hitting denser particles. It will bend. It's just a rule of thumb with this, and you can do it with experimentation. Light will bend towards the denser medium. So as it hits the more denser particles, it'll bend down into the medium air, and if it gets the cold air,
but the
it'll bend down.
representation that we're looking at, that guy, is he supposed to be? What is he seeing?
So what he's seeing
is the whole boat.
What he's seeing is light coming at an angle of this angle here, where my mouse
Yeah, no, I
is
get
moving.
that that's representing the angle of the light. But what is the picture he's seeing? He's seeing the boat?
The next slide is showing you what he's seeing. He is seeing this. And that's this is just a picture of this one here.
Yeah, so that's what he's seeing, but that's the line. But that's what he's seeing. Exactly.
Yeah,
the boat. Seeing. Okay, so that's what he's seeing. Okay, so when you go back, that picture...
What is actually going on, it's something like this, and just the atmospheric conditions are right. So my point is, though, light bends down to this, so which causes objects to appear higher.
Yeah.
So you can't use atmospheric lensing to explain why the bottom of something is disappearing.
Yes, because it's getting rid of that argument.
And the second thing would be that's why I recommend using the sun and moon. The sun and moon don't disappear by
where you might have a better test? I've seen them on some of those lakes where it's like cooler. You're not looking at that atmospheric heat.
Cooler temperatures, you'll get more atmospheric and refraction. I think it's refraction that will be the correct.
If the water's colder and the air's colder?
Yeah, usually.
Really?
That's my understanding. I can... it's the thermal inversion of atmospheric conditions is steep when atmospheric ducts have formed. A thermal inversion conducted where warmer air existed, definite layer. So it's like you need warmer air above cooler air. I think.
So take that P900 and look at put something out, an ice hut. Get 2 ice huts identical, or 3 or 4 things that are identical. Put them at different points on the lake. 1, 2, 2 miles, 3 miles, 5 miles, 7 miles. Give me 7 miles. Okay. 2, 3, 5, 7. Set them beside so you can see them. They're not interfering with things. And then come back and zoom into the one and zoom there, and then look at that and then zoom into the next. If you can keep zooming in from your perspective, and you just see this, then you have to be, for your model to work, that it's round, there has to be something going on, because you're now, how much curvature are you out at 7 miles? It's substantial. In other words, the Earth should be falling away by that much. You should be hitting curvature of the Earth. In other words, you shouldn't be able to see it at 7 miles.
And you can observe that. You can observe, ships disappearing bottom up. Yeah. But for me, I don't think I need to do it. All I think I need to do to prove you up this round is just to simply watch a sunset. Because I go, that they're disappearing by perspective doesn't work,
True. No, it's a really good point. My brain doesn't work that way.
Yeah.
I wish it did.